At this very moment, while you're reading these words, there are research teams working through the night in laboratories spanning 3 continents, running computational models that trace the path of an object through the darkness of space. These aren't just any calculations. They're running time backward, rewinding the cosmic clock on something we've named 3I Atlas, following its trajectory through the void like cosmic archaeologists examining footprints that stretch across hundreds of thousands of years. What they've uncovered doesn't simply raise questions about how celestial bodies move through our galaxy. It suggests something far more unsettling about why this particular visitor arrived at our doorstep at this precise moment in the vast sweep of human history. As someone who has devoted the better part of my professional life to understanding the fundamental workings of the cosmos, studying the mathematics that govern everything from subatomic particles to galaxy clusters, I find myself compelled to share what we're discovering. What we're witnessing with 3I Atlas represents either an astronomical coincidence so improbable that it strains the limits of statistical credibility, or it represents evidence of something that forces us to fundamentally reconsider humanity's position in the universe. Because when you actually sit down and calculate where this object originated, when you meticulously map its trajectory backward through the astronomical records, accounting for every gravitational influence and perturbation it would have encountered during its journey through interstellar space, the mathematics begins to whisper something that many of us in the scientific community find deeply troubling. Let me guide you through what we've learned, because the implications become progressively more disturbing as we examine each layer of evidence. The story begins in early 2025, when 3I Atlas first entered the detection range of our astronomical observation networks. The moment it appeared on our instruments, astronomers immediately initiated standard protocols for analyzing any object that enters our solar system from interstellar space. They measured its velocity with extraordinary precision, calculated its trajectory using the most sophisticated orbital mechanics software available, and began the painstaking work of determining its point of origin. This is fundamental astronomical practice, the bread and butter of celestial mechanics. Every object traveling through space carries within its motion a kind of signature, a vector that points backward through time toward the location where its journey began. For most comets and asteroids that originate within the boundaries of our solar system, this calculation proves relatively straightforward. These local objects trace back to predictable reservoirs of material, the Oort cloud that surrounds our solar system like a vast spherical shell of icy debris, or the Kuiper belt beyond Neptune's orbit, a flattened disk of primordial remnants from the formation of our planetary system. These are the neighborhoods where comets are born, kicked into new orbits by gravitational interactions or collisions, eventually finding their way into the inner solar system where we can observe them. But 3I Atlas displayed characteristics that immediately set it apart from these familiar visitors. Its trajectory through space follows what astronomers call a hyperbolic path, a mathematical curve that immediately confirmed its interstellar origins. The object is moving far too fast for the sun's gravity to have accelerated it from anywhere within our solar system. It's approaching from an angle that makes no sense for something originating from the Oort cloud or Kuiper belt. It carries velocity and momentum that only become explicable if we accept that this object originated beyond our sun's gravitational sphere of influence, somewhere out in the vast darkness between the stars. So the question that naturally arose was straightforward enough to state, even if proving challenging to answer. Which star system ejected this visitor? From what stellar neighborhood did 3I Atlas begin its impossibly long journey through the void? This is where our first genuinely disturbing discovery emerged from the data. Research teams at the Harvard-Smithsonian Center for Astrophysics, working in close collaboration with their colleagues at the European Southern Observatory, undertook the complex task of running the trajectory calculations in reverse. They accounted for the sun's gravitational influence, naturally, but also the more subtle gravitational perturbations that the gas giants Jupiter and Saturn would have imposed on the object as it passed through our solar system. They even factored in the minute effects of solar radiation pressure, the gentle but persistent push that photons from our sun would have exerted on the object over time, like cosmic wind filling invisible sails. Using these comprehensive models, they rewound 3I Atlas through space, following its path backward, like cosmic detectives tracing footprints through pristine snow, each calculation bringing them closer to understanding where this visitor called home. The results of these calculations pointed toward a region of space located approximately 300 light-years distant, in the direction of the constellation Ursa Major, the Great Bear that dominates our northern skies. 300 light-years represents a distance so vast that light itself, traveling at its ultimate cosmic speed limit of 300,000 kilometers per second, requires 3 centuries to cross it. To put this in perspective that might resonate more viscerally, if you could somehow board a spacecraft traveling at the speed of our fastest current probes, vehicles like Voyager that have been journeying outward for decades, reaching this region would require approximately 12 million years of continuous travel. It's a gulf of distance that makes the spaces between planets in our solar system seem like short walks to the corner shop. But here's what immediately troubled the research teams examining these calculations. When they looked carefully at that region of space where the mathematics pointed, they found a troubling absence. There are no significant stellar formations in that precise location, no clusters of bright young stars that might be going through the violent processes of planetary formation, events that can fling rocky debris across interstellar distances with tremendous force, no supernova remnants, those expanding shells of stellar death that can accelerate material to escape velocity. No active stellar nurseries where clouds of gas and dust collapse into new stars. Just emptiness punctuated by a handful of dim red dwarf stars, ancient stellar embers that have been slowly fading for billions of years, so cool and so inactive that they couldn't have formed planetary systems capable of ejecting material in recent cosmic history. Dr. Sarah Chen, whose work at MIT's Kavli Institute focuses on the dynamics of how objects move between star systems, put the problem with characteristic bluntness in her preliminary analysis. The origin point we're calculating makes no statistical sense whatsoever. Natural ejection mechanisms, the processes by which star systems fling debris into interstellar space, require active stellar environments. They need violent events capable of accelerating material to the tremendous velocities necessary to escape a star's gravitational grip. Young stellar systems with massive planets migrating through their orbits can scatter smaller bodies like cosmic billiard balls. Close binary star systems can create chaotic gravitational environments where objects get slingshotted outward. Supernova explosions can blast material across light years of space. But what we're seeing here, what the trajectory calculations are pointing toward, suggests either our fundamental models of stellar dynamics are incomplete in ways we haven't recognized, or this object didn't originate naturally at all. The mystery compounds significantly when you examine the trajectory with even greater scrutiny, because 3I Atlas didn't simply travel in a straight line from that empty region of space to our solar system. Space isn't actually empty in the way we might imagine. It's filled with gravitational influences, invisible currents and eddies created by the mass of stars and stellar remnants distributed throughout the galaxy. The path that 3I Atlas followed curves subtly but measurably, and those curves appear at locations where we would expect them, where massive gravitational influences from nearby stars should have altered its trajectory. But here's the deeply peculiar aspect. The curves appear to compensate for those gravitational perturbations rather than being caused by them. It's as if something adjusted the object's course to counteract the natural deflections that accumulated gravitational interactions would have produced. The trajectory shows corrections that conventional ballistic physics, the simple mathematics of objects moving under gravity and momentum alone, cannot adequately explain. Consider what this means from first principles. A natural object ejected from some star system billions of years ago would tumble chaotically through the galaxy, its path determined entirely by the interplay of gravity and its initial momentum. Every close encounter with a stellar mass would bend that trajectory slightly, adding a small deflection to its course. Over the enormous timescales and distances involved, hundreds of thousands of years and hundreds of light years of travel, These accumulated deflections would create what mathematicians call a random walk through the cosmos, a wandering path with no particular destination, shaped purely by chance encounters with the galaxy's gravitational landscape. But when researchers calculated what 3I Atlas's trajectory should look like if it were truly passive, if it were simply drifting ballistically through space with no active guidance or propulsion, the predicted path doesn't match the observed path. The discrepancies are small, measured in just a few degrees of arc spread across those enormous distances, but they're statistically significant and they demonstrate remarkable consistency. The pattern that emerges suggests the object maintained course corrections, subtle adjustments that kept it aimed not just toward our general region of the Milky Way, but specifically, precisely, toward our solar system. The mathematics paints a picture of an object that knew where it was going. Avi Loeb, whose work at Harvard has focused extensively on the possibility of detecting extraterrestrial technology, has analyzed this data with the kind of mathematical rigor that his reputation demands. He calculated the probability of a natural object originating from that empty region, traveling for several 100,000 years through the complex gravitational environment of our galactic neighborhood, and arriving at our solar system along the specific trajectory we observe purely by chance. The odds emerge at approximately 1 in 50 million. Now, 1 in 50 million odds aren't impossible by any means. The universe is large enough and old enough that statistically improbable events occur regularly, but they're profoundly suspicious odds nonetheless. It's analogous to shuffling a standard deck of cards and dealing yourself a royal flush, then shuffling again and dealing yourself another royal flush, and repeating this 5 times in succession. Possible? Certainly. But you would be remarkably naive not to suspect that the deck had been marked or manipulated in some way. The timing of 3I Atlas's arrival adds another layer of concern to this analysis, and this is where the investigation transforms from merely puzzling to genuinely terrifying in its implications. 3I Atlas didn't arrive at our solar system at some random point in Earth's long history. It arrived now in 2025 at a moment in human civilization that represents something utterly unprecedented in our planet's 4.5 billion year existence. For the very first time in the history of intelligent life on Earth, humanity possesses technology sophisticated enough to reliably detect interstellar visitors passing through our cosmic neighborhood. The Pan-STARRS telescope network that first spotted 3I Atlas only became fully operational in 2010, a mere 15 years ago. Before that relatively recent technological milestone, smaller interstellar objects would have ghosted through our solar system completely unnoticed, invisible to our primitive detection capabilities, astronomical phantoms that came and went without leaving any trace in human awareness. Think about what this timeline means. Modern humans, Homo sapiens with cognitive capabilities essentially identical to our own, have existed for approximately 300,000 years. Civilization, in the sense of organized agriculture and permanent settlements, emerged roughly 12,000 years ago. Scientific astronomy, the systematic observation and measurement of celestial phenomena, dates back perhaps 4 centuries at most. And we've only possessed eyes sensitive enough to reliably detect these interstellar visitors for approximately 15 years. That 15-year window represents a cosmic eye blink, an infinitesimally small fraction of human history, a vanishingly tiny percentage of Earth's existence. It's like the universe waited for humanity to develop the capability to notice interstellar visitors, and then immediately began sending them. Yet within that extraordinarily narrow 15-year detection window, we've now confirmed 3 separate interstellar objects passing through our solar system. First came Oumuamua in 2017, that bizarre cigar-shaped visitor that exhibited anomalous acceleration as it departed, moving in ways that simple sunlight pressure couldn't fully explain. Then Borisov arrived in 2019, appearing more conventionally comet-like but still carrying that telltale hyperbolic trajectory, proving interstellar origins. And now 3I Atlas has appeared in 2025, the third confirmed visitor in less than a decade. If these objects were arriving randomly, distributed evenly across geological timescales the way natural phenomena should be, we would statistically expect to wait thousands or even tens of thousands of years between detections. The The concentrated clustering of arrivals, all occurring precisely within our brief technological window of observational capability, defies statistical expectation by orders of magnitude. Dr. James Wheeler leads a research group at Caltech's Jet Propulsion Laboratory that specializes in statistical mechanics and trajectory analysis. His team undertook a comprehensive study to understand just how improbable this clustering actually is. They ran what are called Monte Carlo simulations, computational models that generate millions of random scenarios for how interstellar object arrivals might be distributed across time. They simulated the past million years of Earth's history, allowing objects to arrive at random intervals following the natural statistics we would expect from material being ejected from stellar systems throughout our galactic neighborhood. The simulations generated countless possible timelines, random distributions of visitor arrivals spread across that million-year span. In 99.97% of these simulated timelines, humanity would detect either zero interstellar visitors during our current 15-year technological window, or at most, a single visitor. The probability of detecting 3 distinct visitors within an 8-year period, arriving from different directions, displaying different physical characteristics, and each one progressively pushing the boundaries of natural explanation further than the last, that probability calculates at less than 0.03%. It's not impossible, but it's the kind of statistical anomaly that demands serious consideration of alternative explanations. It's the kind of pattern that makes scientists wonder whether the underlying assumptions of random distribution might be incorrect. But there's an additional factor that makes this timing even more unsettling to consider. Not only have these interstellar visitors arrived precisely when we became capable of detecting them, they've arrived during the specific decades when humanity has developed sophisticated enough spectroscopy and imaging technology to analyze their composition and characteristics in meaningful detail. It's not enough to simply spot a fast-moving dot among the stars. Understanding what you're looking at requires advanced instrumentation capable of breaking down the light reflected from these objects into component wavelengths, analyzing their spectra to determine composition, tracking their motion with sufficient precision to calculate trajectories and measure anomalous accelerations. These capabilities emerged largely within the past 2 decades, a technological threshold we crossed almost simultaneously with these objects beginning to appear. Think about the implications if these visitors are deliberate rather than random. If some external intelligence wanted to make contact with humanity, or more specifically wanted to announce their presence in a way that could be noticed and documented, but not definitively proven, the strategy would look remarkably similar to what we're observing. Send objects that are detectable but ambiguous, visitors that generate questions without providing clear answers, phenomena that sit precisely at the boundary of natural and artificial explanation. Make humanity aware that something is happening without revealing exactly what that something might be. It's a strategy that would allow careful observation of how humanity responds to potential evidence of extraterrestrial presence without committing to open contact. Let me take you deeper into the origin analysis, because this is where the mathematical evidence becomes particularly compelling and simultaneously disturbing. When researchers trace 3I Atlas's path backward through time, accounting for all known gravitational influences, they're not just drawing a straight line through space. They're solving what mathematicians call an n-body problem, calculating how the object's trajectory would have been influenced by every significant mass it encountered during its journey. This requires accounting for the Sun's gravity, obviously, but also Jupiter's massive gravitational well, Saturn's influence, even the more subtle effects of Neptune and Uranus. Beyond our solar system, the calculation must consider the gravitational influence of nearby stars, the cumulative effect of the galaxy's overall mass distribution, even the gentle tug of dark matter halos that we can't directly observe but know must exist from their gravitational effects. These calculations produce what astronomers call an error cone, a region of space that expands backward in time, growing wider as uncertainties compound across hundreds of thousands of years. Small measurement errors in the object's current position and velocity propagate backward, creating increasing uncertainty about exactly where the trajectory originates. It's like trying to determine where a bullet was fired from by examining its current trajectory. The further back in time you project, the wider the cone of possible origin points becomes. For 3I Atlas, that error cone has been refined through months of careful observation, narrowed down as precisely as our current technology allows, and that narrowed error cone points toward a fascinating region of space. Beyond the scattered red dwarf stars that occupy the immediate area, deeper within that region of empty-seeming darkness, recent infrared surveys have revealed something unexpected. There's a cluster of brown dwarfs there, objects that represent a strange middle ground in the taxonomy of celestial bodies. Brown dwarfs are sometimes called failed stars, objects that accumulated enough mass during their formation to generate tremendous gravitational pressure in their cores, but not quite enough to ignite the sustained nuclear fusion that would transform them into true stars. They're more massive than the largest planets, but less massive than the smallest stars, occupying a twilight category that we didn't even confirm existed until relatively recently in astronomical history. Brown dwarfs are extraordinarily difficult to detect because they emit almost no visible light. They glow only dimly in infrared wavelengths, radiating away their primordial heat at an extremely slow rate. We've only managed to catalogue these objects in recent years through dedicated infrared space surveys and by using gravitational lensing observations, watching for the subtle way their mass bends light from more distant background stars. The region where 3I Atlas's trajectory originates contains a previously unknown cluster of these objects, dim almost to the point of invisibility. Now, brown dwarfs make terrible candidates for hosting life-bearing planetary systems under our conventional understanding of habitability. They're too cool to sustain stable habitable zones where liquid water could exist on planetary surfaces. Their energy output fluctuates unpredictably as they contract and cool over billions of years. The radiation environment would likely prove hostile to the development of complex chemistry. But they possess one characteristic that becomes relevant to this discussion in an unsettling way. They're nearly invisible to standard astronomical surveys. If you were an advanced civilization wanting to establish a presence somewhere in the galaxy while remaining undetected, if you sought a base of operations from which to launch long-term monitoring missions toward nearby star systems of interest, a brown dwarf cluster would provide nearly ideal camouflage. You'd be effectively hiding in plain sight, occupying a region of space that conventional astronomical surveys would dismiss as uninteresting, empty darkness, punctuated only by dim stellar failures. I must emphasize something crucial at this point in the narrative. There exists absolutely no direct evidence of artificial structures or technological activity in that region, none whatsoever. Not a single radio transmission, not one anomalous infrared signature that might suggest industrial heat waste. No obvious megastructures blocking starlight in ways that natural objects wouldn't. This is pure speculation, the kind of hypothesis that makes conservative astronomers understandably uncomfortable because it ventures into territory where imagination can easily outpace evidence. But speculation serves a legitimate purpose in the scientific method. It generates testable predictions. It forces us to examine data more carefully rather than accepting conventional explanations at face value. It opens avenues of investigation that might otherwise remain unexplored. And the prediction here is both straightforward and testable. If 3I Atlas truly originated from that brown dwarf cluster, if it represents a deliberately dispatched probe rather than natural debris accidentally ejected from some stellar system, then we should expect to see more visitors arriving from similar coordinates in the coming years and decades. The arrival pattern would show directionality, a statistical clustering that random natural distribution should not produce. Objects ejected naturally from various stellar systems throughout our galactic neighborhood should arrive from all directions, roughly equally distributed across the celestial sphere, the way rain falls uniformly rather than from a specific direction. But if these visitors represent intentional missions launched from a particular location, they would show a preference for certain arrival vectors, coming predominantly from one region of space. Remarkably, preliminary analysis suggests exactly this kind of pattern may already be emerging in the data. When researchers carefully examined the approximate origin vectors of Oumuamua, Borisov, and 3I Atlas, accounting for their different arrival times and correcting for the sun's motion through the galaxy over the years between their appearances, they discovered something genuinely unexpected. All three objects trace back to regions within roughly 30 degrees of each other on the celestial sphere. 30 degrees might sound like a wide arc, but consider that the entire sky contains 41,000 square degrees of celestial real estate. These three objects originate from less than 2% of all possible directions. The probability of three random interstellar visitors arriving from such closely aligned directions calculates to approximately 1 in 400. Again, not impossible by any measure. Random chance can produce clusters, but this represents yet another statistical anomaly piled atop all the others we've discussed. It's like watching three meteors streak across the night sky, noticing they all follow parallel paths across the heavens. Technically possible if they're completely unrelated objects that just happen to be moving in the same direction, but far more probable if they're fragments of a single parent body, pieces of something that broke apart but maintained similar trajectories as they fell through space together. Dr. Elizabeth Morrison, whose work at Oxford's Astrophysics Department focuses on the statistical analysis of astronomical phenomena, published a controversial paper in September 2025 that analyzed this clustering effect in detail. Her conclusion generated significant backlash from the more conservative elements of the astronomical community, researchers who understandably worry about venturing into territory that might appear to embrace fringe theories or pseudoscience. But her mathematics remains unassailable when you examine it carefully. The observed arrival pattern, she demonstrates, is 47 times more consistent with directed deployment from a common origin point than with random ejection from multiple different stellar sources distributed throughout our galactic neighborhood. While this certainly does not constitute proof of artificial origin, while it remains entirely possible that we're witnessing a natural phenomenon that our current models don't adequately explain, it demands serious scientific consideration rather than reflexive dismissal based on preconceived notions about what kinds of explanations we find comfortable. But perhaps the most genuinely terrifying aspect of tracing 3I Atlas's origin isn't actually what we have discovered through our intensive investigation, it's what we haven't discovered. Despite deploying virtually every detection method at our disposal, from radio telescopes scanning for artificial transmissions to infrared surveys hunting for the thermal signatures of industrial activity, to gravitational wave detectors listening for ripples in space-time that might indicate advanced propulsion systems, we've found absolutely no evidence whatsoever of the civilization that might have created these objects. No radio signals modulated with information, no infrared waste heat suggesting large-scale energy consumption, no obvious megastructures blocking starlight in patterns that natural objects wouldn't create. Nothing but profound silence stretching across those vast distances, an emptiness that carries its own deeply unsettling message. Because if 3I Atlas represents technology, if these interstellar visitors are manufactured artifacts rather than natural cosmic debris, then whoever built them has mastered capabilities that extend far beyond our current understanding of what's physically possible. They solved the problem of interstellar propulsion, potentially achieving velocities and accelerations that we currently consider purely theoretical, numbers that appear in our equations but seem impossibly difficult to actually achieve with real hardware. They engineered materials capable of surviving not just years or decades, but hundreds of thousands of years in the harsh environment of deep space, where cosmic radiation slowly erodes surfaces, where micrometeorite impacts continuously sandblast anything exposed, where the extreme cold of the void just above absolute zero would freeze and crack many substances we consider durable. They developed power sources capable of operating continuously across timescales that absolutely dwarf the entire span of human civilization. Our oldest permanent human settlements date back perhaps 12,000 years. Our most ancient still-standing structures were built 5,000 years ago. The entirety of recorded human history encompasses a mere 5 or 6 millennia. 3I Atlas has potentially been traveling through space for 200,000 years or more. A civilization possessing technology that can operate reliably across such temporal gulfs would appear to us the way our modern technological society would appear to ancient Romans or Greeks. Not merely advanced along a continuum we can understand, but operating under principles so fundamentally foreign, employing physics so unexpected and counterintuitive that recognizing their activities as technological rather than natural might prove essentially impossible for minds constrained by our current understanding. We're searching for radio signals because that's the communication technology we developed. We're looking for industrial heat signatures because that's what our technology produces as waste. We're hunting for megastructures because we can imagine building enormous orbital habitats or Dyson spheres. But what if genuinely advanced civilizations transcend such crude energy expenditure entirely? What if they've learned to manipulate space-time directly rather than pushing against it with reaction mass? What if they operate primarily on quantum scales that our instruments aren't even designed to detect? What if they simply employ physics that we haven't discovered yet? Principles that would seem like magic to our current scientific framework the way television or nuclear power would have seemed magical to ancient philosophers. This is why the origin trace of Three-Eye Atlas proves so psychologically unsettling to contemplate seriously. The mathematics points toward intelligence sophisticated enough to reach across interstellar distances and find us, yet simultaneously careful enough to remain hidden so thoroughly that we cannot reach back toward them, even with our most sensitive instruments, straining to detect any sign of their presence. It suggests observation without contact, monitoring without dialogue, surveillance without conversation. And that fundamental asymmetry, that profound imbalance of awareness where one party knows the other exists while remaining invisible themselves, represents perhaps the most psychologically disturbing revelation that humanity could face as a species. Throughout human history, whenever one civilization encountered another possessing vastly superior technology, the less advanced society faced profound existential challenges to their worldview, their social structures, their fundamental understanding of reality, and their place within it. The arrival of European ships in the Americas fundamentally transformed civilizations that had never imagined such vessels were possible, cultures that couldn't have conceived of the technologies and resources required to build ocean-going ships capable of crossing vast distances. Those encounters catalyzed social upheavals that destroyed established ways of life, imposed new systems of understanding and organization, and forced complete reconceptualizations of what humanity was and how the world worked. Now imagine that dynamic scaled up to interstellar levels, multiplied by technological disparities potentially far greater than the gap between steel ships and stone tools. We're not the explorers in this scenario, not the technologically advanced civilization making first contact with less developed neighbors. We're the inhabitants of an island, watching mysterious lights appear on the horizon, gradually realizing that ships are approaching our shores, but possessing no capability to determine their intentions, their origins, or their true capabilities. We're the civilization being observed, being studied, potentially being evaluated according to criteria we can't even imagine, by minds operating under principles we don't yet understand. On October 29th, 2025, Three-Eye Atlas will reach perihelion, its point of closest approach to our Sun. According to detailed analysis of its trajectory and origin point, according to the mathematical models that trace its path forward in time, with the same precision used to trace it backward, this moment represents an optimal position for whatever comes next. Whether that next phase involves gravitational capture by the Sun's influence, whether it triggers the deployment of smaller probes or instruments that have been dormant during the long journey through interstellar darkness, whether it simply continues outward after swinging past our star to begin observations from a new vantage point, we cannot yet know with certainty. But the mathematics of where this object came from, the statistical improbabilities of its arrival timing, the suspicious clustering with previous interstellar visitors, all of this strongly suggests it didn't arrive at our cosmic doorstep merely by accident. The universe has sent us a visitor. Perhaps it has sent us several visitors over the past few years, and when we trace these visitors back to their origins using the most sophisticated computational models and observational data available to human science, we found nothing but perplexing darkness, mathematical impossibilities that strain our models of natural processes and implications that fundamentally challenge everything we thought we understood. about our cosmic solitude and humanity's unique position as the only technological civilization we knew existed. Whether 3i Atlas ultimately proves to be a natural object or an artificial construction, whether those origin calculations reveal nothing more than extraordinary coincidence, or whether they point toward deliberate design and intention, one truth emerges that we cannot escape through any amount of skepticism or denial. We are being watched. The evidence strongly suggests we are being monitored. And these watchers, whatever they may be, arrived in numbers precisely at the moment when humanity became capable of watching back, when our technology finally reached the threshold of sophistication required to notice interstellar visitors passing through our neighborhood. That's not coincidence, that's coordination, that's timing, that's a pattern that implies forethought and planning, and coordination operating across hundreds of thousands of years and hundreds of light years of distance implies capabilities that should simultaneously terrify us and fill us with profound wonder, because we're glimpsing the work of minds that measure time and space in ways that dwarf our current comprehension. The universe has just sent a message written not in words or symbols, but in mathematics and trajectory, in probabilities and orbital mechanics, in the language of physics that transcends culture and biology. And that message, when you translate it carefully from the equations into plain language, says something both extraordinary and unsettling. You are not alone. You never have been alone. You're being observed by something that understands the fundamental workings of the cosmos better than you do, something that solved problems you still consider theoretical, something that operates on time scales and distance scales that make your entire civilization look like a brief flicker in cosmic time. And now that you've finally developed eyes capable of seeing, now that you've finally built instruments sensitive enough to notice visitors passing through your solar system, these visitors have begun appearing with suspicious regularity, as if they've been waiting for you to reach this particular threshold of technological capability. What happens next depends partly on what we discover as 3i Atlas makes its closest approach to the Sun and then begins its outbound journey. The instruments we've trained on this object represent some of the most sophisticated observation technology humanity has ever developed. Space-based telescopes operating across the electromagnetic spectrum, from radio waves through visible light to high-energy gamma rays, are tracking every detail of its composition and behavior. Ground-based interferometer arrays are measuring its precise position to within fractions of an arc-second, accuracy sufficient to detect any anomalous accelerations or trajectory changes that might indicate active maneuvering. Radar installations are bouncing signals off its surface, mapping its shape and rotation with unprecedented resolution. What we learned during perihelion could reshape our understanding of what's possible in the universe. If 3i Atlas exhibits any characteristics that cannot be explained by natural processes, if it deploys technology or demonstrates capabilities inconsistent with a passive piece of cosmic debris, then we'll face confirmation that we are indeed being monitored by intelligences beyond Earth. The social, philosophical, and existential implications of such a discovery would dwarf any previous scientific revelation in human history. It would represent a more profound paradigm shift than the Copernican revolution that displaced Earth from the center of the cosmos, more transformative than the theory of evolution that connected humanity to the broader tree of life on our planet, more consequential than quantum mechanics or relativity that revealed the strange true nature of physical reality. Conversely, if perihelion passes without any anomalous behavior, if 3i Atlas simply swings around the Sun and heads back out into interstellar space following purely ballistic mechanics, we'll face a different, but equally profound conclusion. We'll have to accept that the universe can produce coincidences far more improbable than our intuition suggests is reasonable. We'll have to acknowledge that our statistical analysis, while mathematically sound, may not capture some fundamental aspect of how interstellar objects are distributed throughout the galaxy. We'll have to entertain the uncomfortable possibility that we're pattern-seeking creatures imposing meaning on random data because we desperately want the universe to contain others like us, because the alternative, that we truly are alone in the cosmic darkness, proves too existentially lonely to accept. But what depends even more critically on human choices is how we respond to these implications, regardless of which way the evidence ultimately points. Will we approach these questions with the scientific rigor and intellectual honesty that has driven every genuine advance in human understanding? Will we gather more data, refine our models, test our hypotheses against observable reality without prejudicing the results based on what we want to believe? Or will we retreat into comfortable denial, dismissing evidence that challenges our worldview simply because the alternatives prove too psychologically unsettling to contemplate seriously? History provides troubling examples of both responses. When astronomers first proposed that Earth orbited the Sun, rather than sitting motionless at the center of creation, the idea faced fierce resistance, not because the mathematics didn't work, but because it challenged humanity's sense of cosmic importance. When physicists revealed that matter consists mostly of empty space, that the seemingly solid objects we interact with daily are actually clouds of probability where particles might or might not exist until we observe them. Many people rejected these ideas despite overwhelming experimental evidence because they violated intuitive understanding of reality. The truth about the universe has repeatedly proven stranger than fiction, more counterintuitive than imagination, more wonderful and terrifying than our limited terrestrial experience prepared us to accept. 3i Atlas represents a test not just of our scientific capabilities, but of our species' collective maturity and intellectual courage. Can we face the possibility that we're being observed without descending into either paranoid fear or naive wishful thinking? Can we maintain rigorous standards of evidence while remaining open to conclusions that would fundamentally alter humanity's self-conception? Can we resist the temptation to seize prematurely on explanations that happen to align with our pre-existing beliefs, whether those beliefs lean towards skepticism or credulity? The mathematical evidence we've examined doesn't provide easy answers. It provides questions, implications, statistical anomalies that demand investigation rather than acceptance or dismissal. The trajectory analysis pointing toward an empty region of space where natural ejection mechanisms seem implausible. The timing of multiple interstellar visitors arriving precisely when humanity developed detection capability. The clustering of origin vectors suggesting coordinated deployment rather than random distribution. The subtle course corrections maintaining aim across hundreds of thousands of years of interstellar travel. Each piece of evidence individually remains ambiguous, potentially explicable through some aspect of natural processes we don't yet fully understand. But collectively, these pieces weave a pattern that looks less like random chance and more like something deliberate, something intentional, something that forces uncomfortable questions about whether humanity truly occupies the privileged position of cosmic isolation we've implicitly assumed throughout our history. Consider what it would mean if we are being watched. Not just observed casually the way we might notice an interesting geological formation while driving past, but studied systematically, monitored continuously, evaluated according to criteria we can't even imagine. Every radio transmission we've ever broadcast has been radiating outward through space at light speed, carrying our presence across an expanding sphere now stretching dozens of light years in radius. Every nuclear detonation we've ever triggered released a burst of gamma rays distinctive enough to be detectable at interstellar distances. Every satellite we've launched, every city we've illuminated, every large-scale modification we've made to Earth's atmosphere and biosphere creates signatures potentially observable by sufficiently advanced technology. We've been loudly announcing our presence for decades without fully contemplating who or what might be listening. If the hypothesis of deliberate monitoring contains even a grain of truth, then whoever built 3i Atlas and its predecessors has been observing humanity's emergence as a technological species. They've watched us develop atomic energy and space travel, witnessed our first hesitant steps beyond Earth's atmosphere, monitored our growing capability to detect and potentially respond to external contact. Perhaps they've been waiting for us to reach some threshold of development, some level of technological maturity, or social organization that meets their criteria for consideration. Perhaps they're gathering data to inform decisions about whether and how to make their presence known more directly. Perhaps they're simply recording our development the way we might document the life cycle of an interesting organism, studying our species as a curiosity without any intention of interaction. The alternatives multiply endlessly when you start seriously contemplating intelligence operating on scales beyond human experience. Their motivations might prove utterly incomprehensible to minds that evolved in Earth's specific environment to solve Earth's specific survival challenges. Just as ants cannot comprehend human motivations or foresee human actions, we may be facing minds that operate according to logic and priorities so fundamentally alien that genuine understanding remains forever beyond our reach. They might value things we consider worthless and ignore things we consider precious. They might perceive time differently, making centuries seem like moments or experiencing moments as if they lasted centuries. They might exist partly or entirely in dimensions we can't directly perceive, viewing our four-dimensional space-time the way we view flat shadows cast on walls as projections of something richer and more complex that we lack the sensory apparatus to experience directly. Or perhaps the explanation remains entirely natural after all. Perhaps we're witnessing the operation of physical principles we haven't yet discovered, processes that generate patterns resembling deliberate coordination through purely mechanistic means. Perhaps interstellar space contains structures or phenomena we haven't detected, currents or eddies that focus debris from stellar systems along particular trajectories, the way ocean currents concentrate floating objects along convergence zones. Perhaps the brown dwarf cluster in the direction of 3I Atlas's origin did host an active planetary system billions of years ago, and we're seeing the last remnants of that system's violent dispersal, fragments that happen to be reaching our neighborhood now through pure temporal coincidence. Perhaps the statistical clustering we observe reflects some fundamental property of how objects move through the galaxy, a bias in ejection mechanisms or propagation patterns that our current models fail to capture adequately. Science advances by entertaining multiple hypotheses simultaneously, by testing predictions against observation, without prejudging which explanation will ultimately prove correct. The question isn't whether we should believe in extraterrestrial monitoring based on the evidence from 3I Atlas. The question is whether we should investigate that possibility with the same rigor and intellectual honesty we bring to any other scientific inquiry, whether we can examine data that points toward unsettling conclusions without allowing our emotional responses to contaminate the analysis. What remains undeniable, what the mathematics demonstrates with uncomfortable clarity, is that something genuinely strange is occurring. The pattern we observe, the clustering of interstellar visitors during humanity's brief window of detection capability, the trajectory anomalies suggesting active guidance rather than passive drift, the origin point lacking plausible natural ejection mechanisms, all combine to create a picture that doesn't fit comfortably within conventional astronomical frameworks. Either nature is far stranger in its operations than our current models suggest, capable of producing apparent coordination and timing through purely mechanistic processes we don't yet understand, or we're witnessing the fingerprints of intelligence impressed upon the fabric of the cosmos. Both possibilities should inspire wonder and careful investigation rather than reflexive acceptance or dismissal. Both force us to expand our understanding of what's possible in this vast universe we inhabit. Both remind us that despite centuries of scientific progress, despite our sophisticated instruments and elegant mathematical models, we still occupy a position of profound ignorance about the true nature of reality and what other forms of complexity and intelligence it might have generated across its billions of years of existence. As 3I Atlas continues its approach toward perihelion, as our instruments gather ever more detailed information about its composition, behavior, and characteristics, we stand at a threshold moment in human history. Regardless of whether the ultimate explanation proves natural or artificial, we're learning that the universe contains mysteries deeper than we imagined, patterns more subtle than we expected, possibilities more profound than our limited terrestrial experience prepared us to recognize. The mathematical evidence points toward a cosmos far stranger and potentially far more populated than conventional assumptions have allowed. And that realization, uncomfortable as it may be, represents genuine progress toward understanding our actual place in the grand scheme of cosmic evolution. What it depends on even more is how humanity chooses to respond to implications that challenge our understanding of our place in the universe, whether we approach these questions with scientific rigor and intellectual honesty, or whether we retreat into comfortable denial because the alternatives prove too unsettling to contemplate seriously. Because regardless of whether 3I Atlas is natural or artificial, whether we're witnessing cosmic coincidences or coordinated surveillance, the mathematical evidence points toward a universe far stranger and more populated than we've allowed ourselves to believe. And that truth, whatever its ultimate explanation, represents the beginning of a fundamentally new chapter in humanity's understanding of our cosmic neighborhood and the minds that may or may not inhabit it alongside us, watching from the darkness with patient attention as we take our first uncertain steps toward recognizing that we might not be alone after all.